All right, so I'm going to work out this problem for you right here on the board so that you have a video that you can look at. I hope that this is going to be working just fine and I'm not messing up anything now. Let's go. What we want to do, we want to find Riemann sums of the function x squared minus 7 from the interval from 5 to 20, and we're going to be using 75 of those rectangles. And that means now summing them up all by hand, one at a time, is an extreme tedious procedure. We are going to be using our rules for summations to simplify this. It will still take us a little bit, but we are going to get through it. All right, so let's do this slowly. The first thing that we will always do is that we always have to find delta x. Delta x being the distance between each rectangle, so the width of all of these rectangles. And with our information right here, we are getting out of this 20 minus 5 divided by 75, and that will simplify down to 1/5. All right, now this delta x will stay the same for both Riemann sums. We are only going to look at the left Riemann sum and the right Riemann sum. So, let's have a look at the left Riemann sum. So for the left Riemann sum, I need to find this input value that I have to use to determine the height of my rectangles. And if I just write down the general form, then it would look like this. And now I'm plugging in my specific values that I have been given out of my information here. A being 5 plus k minus 1 times 1/5. And if I simplify this, then I'm going to end up with k plus 24 all over 5. All right. Now I write down my Riemann sum. Let me first write down the general form. And now we're going to turn this into a left Riemann sum. One more time. This right here is the height of each rectangle, which is different all the time. This right here is going to be the width of each rectangle, which will stay the same. So, what are we ending up with? Let's see. N, in our case, is 75. And f of x sub k star, this right here has to be plugged into our function, and we are going to end up with, let's see, k plus 24 divided by 5 squared minus 7. Now we have to multiply it by the width of the rectangles, which is 1/5. Now this right here, this expression, I'm just going to simplify. I'm going to do this somewhere over here on the side. Let's say over here, so that my whoops, goodness gracious, simplify. All right, so what are we going to do with this? We are going to multiply the top out, which is k squared plus 24 times k times 2, which is 48. And we are ending up with plus 576 all over 5 squared, which is 25. minus 7 multiplied by 1/5. All right, if I move on, if I continue this journey, I have to subtract 7, so I'm going to take 7 times 25, that is 175. I subtract that from 576. I will end up with the polynomial, basically, k squared plus 48k plus 401 divided by 5 times 25, which is 125. Now this right here, I will take and I will plug it into my sum. In other words, I'm going to replace this here. Okay, so what do I end up with? The sum from 1 to 75 of exactly this expression. Actually, let me just copy this. Okay. Could put it in parentheses. So now I'm going to do exactly what we have done before. I'm going to use the rules for summations to pick this apart, and I'm going to turn this into 3 sums altogether. The factor of 1 over 25 I'm going to take out of my sum. 1 over 125 multiplied by, let me first write down the sums, how they will look like before we are using our rules. K squared plus 48 times the sum of the first 75 k's plus the sum of the first 75 401s. All right. So now it's just a matter of doing some simple math. K squared, the sum of the first n squares is n times n plus 1 times 2n plus 1 divided by 6. My n being 75. 75 times 75 plus 1 is 76, times 75 times 2 plus 1 is 151, divided by 6. And here's a good tip and hint. This 6 down here in the denominator, that will always cancel out. Now I add to this 48 times, let's see, first case, so that would be just 75 times 76 divided by 2 plus 75 times 401. And this will give us 2,482.6. That was the left Riemann sum. Now when I do the right Riemann sum, I have to be relatively close to this number. The right Riemann sum actually will be a little bit bigger because it will end up being an overestimate. So let's go ahead. No, where is it? There it is. Now for B, delta x is still 1/5. But because I'm looking at the right Riemann sum, I have to use a different input inside my function. And in that case, x of k star is going to be a plus k times delta x. This will be the easier calculation. Next week, when we're actually evaluating integrals using the definition of Riemann sums, we will always be using this one right here. So a is 5. K is 1/5, delta x is 1/5 times k will be k over 5. Add these two together and you get k plus 25 over 5. Good. Now we are setting up our sum. So just like before, because it is a good habit, I am going, not n, k in this case, technically this can be any letter. We are writing down the general form. And we are going to say now that this form right here, because I'm using the right Riemann sum, which changes again the input of my function, is going to turn into the following. 75. Now, let's have a look. The function is the same as before, so it was the input squared minus 7, and we are ending up with k plus 25 over 5 squared minus 7 multiplied by 1/5. And now, just like before, we're going to take this expression and we're going to simplify it. So I'm going to copy it again. And just like before, I like to do it on the right-hand side. We're going to simplify this expression. We're going to multiply out the numerator, which is over 25. So we're going to get k squared plus 50k plus 625 over 25. Subtract 7 from this and multiply everything by 1/5. All right, so if I subtract 7 from this, we're actually going to subtract 175 over 25, common denominator. And we will end up with, a moment, let me actually look at here, 450. K squared plus 50k plus 450 over 125. All right. So, right here, we are taking now our sum and we are taking it to new heights. Here it is. Let me copy it and drop it inside as a sum. And now, just like before, I will pick this slowly apart and I will turn out of this one sum of the polynomial 3 sums where we then can use our simple rules to find out what value I will get. So, as before, 1 over 125. Let's see. Did I use parentheses or brackets? It doesn't make a difference. 75, k is equal to 1 of k squared, plus 50 this time. K is equal to 1 to 75 of the k's. So the first 75 integers you basically add up here. (75) and you add 450, 75 times in a row up by itself. All right, so we are ending up with 1 over 125 multiplied by, this is the exact same statement that we had just a moment ago with the left Riemann sum, this sum right here, which was 75 times 76 times 151 over 6. The only thing that is different in this middle term is that we are not multiplying it by 48, but 50. 50 times, what is it? 75 times 75 plus 1, which is 76, over 2. And we add to this 75 times 450. And when we are calculating this out, we are going to get 2,575.6. All right. Now, I hope that this will help you. You guys all have a good afternoon. Enjoy.